I'm going to break this down in our Colab so that we can actually understand it in way more detail than just this line of code. So let's break down those variables. So I'll just put it here. So the first thing that we're going to do is get the shape as well as these values. We call it boxes, and IM0, that shape. The reason why this is going to be called boxes is because if I step into this, let me run this. Now we're inside general.py, and this function calls it boxes. So to have the same nomenclature, that's what I just did. And then similarly here, you see mg1 underscore shape and mg0 underscore shape. Those are the names that are defined within this function. So I want to maintain those names so we can keep as much of the code unchanged. So let me run this. So you can see we have our 640 by 640 height and width. This is our current size of the image. Then we have our bounding box coordinates, xy, xy. And then we have our original image of this height, width, and channels. And what we're going to do here is very similar, if not identical, to what we did right here above when we were using the letterboxing. So here we want to calculate the gain, and the gain is calculated as the minimum between our 640 by 640, which was padded, as we know, 80 on the top and 80 on the bottom. We want to know what that ratio is between that padded image and the size of our original image. So we know that the height was 768 and the width 1024. So we want to know what that ratio is, and we want to get the minimum in a similar fashion as we did with our letterboxing. Let me actually run this section. And also I'm going to run these helper functions because we're calling it inside the letterboxing. So let me actually stop that. Let's run the helper function first and then letterboxing. So let's go here. Of course, our input image, nothing new here. And then remember here, our R is the minimum between those two images, which basically is the same that we're doing at the bottom. So we went from this size image. This is a good summary here. And I actually added this one. When I was doing the letterboxing function, we finished here, but as I was doing the other one, I decided to add this here. And of course, we're calling this helper function. That's why we needed to run that one first. So we went from this size image to this one, 480 by 640. And the ratio between this one and this one is 0.625, is this minimum. This 0.625. And then to that, we added the padding. So right now we're calculating basically the inverse between our input image and our padded image. We're calculating, you see the 640 divided by 768 and 640 divided by 1024. We get the minimum of that ratio, which is 0.625. And then we use that to calculate these dimensions and therefore also the padding. So I know this is a little confusing, so let me try to explain it better. Let me go back here. And let me run this and then this one, and I think it will make more sense. So let me actually do one thing here. Let me get this function here. And this is the inverse of what you saw above. We're calling the same helper function, but the order on the sequence. The one above, that was from the input to the padded image. But now we are here. This is our sort of our input. We have our padded image, and we want to, now that we have the prediction, we want to scale it back to the original size image. So basically here, given that this is what we have coming in now into rescale boxes, we want to know what is that ratio that allowed us to go from this size image to this size image. So in this case, in order to know what was the padding, what we're calculating is the minimum between this image and this image of that ratio, and then subtract to this size to know in which side we actually added the padding. So in this case, this operation is going to be 640, so that is 0. And then 640 minus, this is going to be 480. So this operation will be 160 divided by 2 will be 80 of padding on both sides. So this is in a way just the inverse of what we did when we went from here to there. In this case, now we want to calculate the padding, and these are kind of the operations that allows us to do that. So now we have our padding, even though we already knew it coming from the top, but we're just calculating it here again as well.